There's a lot of talk about the next big thing in survey, whether it's AI, autonomous robots, drones, LiDAR, or lasers. Technology is changing faster than a lot of us can keep up with. So in this video, I'm going to show you the next evolution in RTK, and that is the addition of an integrated laser unit in the receiver. So I'm going to show you everything you need to know to see if lasers actually make sense for you. We're going to talk about how you can use lasers, the limitations, how it stacks up against current day technology, and how it could save the lives of surveyors across the world. One of the first things I want to get into here is just how dangerous surveying actually can be. There's some times where maybe you have to take a shot right in the center of the road, and traffic control, as you and I both know, can actually be pretty difficult to do if we're just trying to take one shot. 5 to 10 surveyors every single year in the US are actually killed by traffic while surveying. Now, it's something that I want to get into because we might not think that it's that dangerous, but this is something that applies to your life, and it's actually near and dear to our hearts. We had a customer who actually was struck and killed by traffic while on the job. And the beauty with laser RTK, and I'll get into this and show you how it's done after the fact here, you can stand off to the side of the road and still get that center line point from an actual safe distance. All right, before we go on the field and I show you how to take a shot with this laser receiver, I'm gonna first show you how it works on the board. Here is our lovely Lux receiver. There's gonna be 3 factors that come into when we're taking a laser shot. First is going to be we get our point, our X, Y, and Z coordinates from our RTK within the receiver. The actual laser itself is going to calculate the distance, and the tilt IMU sensor within the receiver as well is going to account for the tilt, because when we take a shot with a receiver, we need to tilt it forward or tilt it up to point where we're trying to shoot. Now there's 3 limitations when we're using laser RTK. The first one is going to be reflectivity. Depending on the type of surface that you're shooting can determine how far away from your point you can be. If it's more reflective, you can be further away. If it's less reflective, you have to be closer. For example, if you're shooting a concrete block, you're gonna have to be a lot closer than if you're shooting aluminum siding on a building. One is more reflective, one is not. Because the flatter and smoother your surface is, the more reflective it's going to be. Number 2 is line of sight. Just like a total station, if you don't have a clear line of sight to your point, you can't take that point. So keep that in mind. Number 3 is distance. Distance is arguably the most important of these 3 limitations. The unit itself is spec'd for 2.5 centimeters at 5 meters of distance. The further away you go, the less accurate you're going to be. So do also try to get as close as you can to the point without putting yourself in danger. All you need is a GeoMeasure Lux receiver. In my case, I'm using an Archer 4 with GeoMeasure's Survey Crew software on it, and we are also hooked up to a network. So let's go in the field and see how easy this thing is to use. So now we're at a culvert here. I'm gonna just try and show you what it would be like to do a quick as-built, or maybe we're just doing a routine checkup and I'm just trying to take some points and I don't really want to get the hip waders on. That's something we don't have to do with laser RTK. So let me show you how it's done here. I'm just gonna take a shot of this concrete block in the middle here, just checking for deformation to make sure it's staying in the same spot. Maybe we'll come back in a week or so and see if it's sunk at all. Well, my name's not Isaac, but hello to you too. Let's take a shot right there. Okay. Take a shot over here. Very good. Now, for the sake of this example, we're just going to take a couple points, but if I was trying to do this for real, obviously with this laser RTK, you can walk around the whole thing, staying outside, staying dry, and getting all the points you need to get from a distance. So as I kind of broke down for you before, I need to take a shot on this road on the center line, but I don't want to put myself in danger. As you can see, there are lots of vehicles moving back and forth here, so we're going to be able to do it again safely from the side of the road using the laser receiver. Let's give it a shot. We're now in this screen where we're saving our point. We can name it something else. Currently it is named Pipe 5. So let's just get rid of this. There we go. Okay. And we're just gonna switch the name of this to 5. Very good. And we're just gonna hit OK. That's our first point. We can then move along our road to our next point here, waiting for the vehicles, take a shot, so on and so forth. You can go down the entire road, however long you need to go, and you can take points at that center line so you know where it is safely without having to put yourself in danger. If you guys are doing utility work and you need to mark out all of these power poles, but you don't really want to go up to each and every one of them, you're just walking down the road. This keeps it nice and simple. We can stay right on the center of the road. We can put it down, we can point, and we can shoot. We're gonna hit OK, and let's go. There's a large bush in the way, so this is another great example. Maybe I don't wanna have to get my face all in this bush. I can stand here right in the center of the road and take my shot without having to get a face full of leaves. We can store our point, hit OK. Let's move to the next one. Now, it's important to mention this is not a miracle technology. Lasers still need line of sight and things still get in the way of what you're trying to take a shot on. So just keep that in mind when you're moving from point to point like we are right now. This grass is in the way of our shot. So we might have to adjust, we might have to offset our point just a little bit up to be able to take the shot with a clear line of sight. So we're back at the office here, and while we are here, I'm gonna take advantage of our lovely little sign by the door. There's a nice crosshair there, and we're gonna test the accuracy of this unit and show you on screen. So we're gonna take one point right from where I'm standing here. Just gonna wait for our camera to initialize. Take one shot there, that's 0.9. We're gonna hit OK. We're gonna move over here, and we're gonna take that same point from a different angle. That's 0.10. We're gonna hit OK. And now we're just gonna put our attention on the screen here. We're gonna go out of our survey laser screen. We're gonna come into tools, hit inverse calculation. Then we can take these 2 points. If we come into here, gonna come and hit 0.10, hit OK. We want to use 0.9. Okay, there we are, and we're gonna hit calculate. Now, if we look at the screen, you can see your distance 2D. Our result is 3/100 of a foot. This unit is spec'd for 2 centimeters at 5 meters of distance. Now, we're seeing 3/100 of a foot. 2 centimeters is about 6 to 7/100 of a foot, so we're doing well above what we should at this distance. Now, if you have any questions, feel free to leave them in the comments below. If you wanna learn more about the Lux and what it can do, including the AR stakeout, go check out this video.